Okay, this time we're gonna solve using Laplace transform a single differential equation. For example, y prime plus y equals to 3 times e to the power of 2 multiplied by x. And this equation subject to the initial value condition of y evaluated at x being 0 equals 0. So in the 0, 0 point. To do that, by means of Laplace transforms, we have to keep in mind some immediate transforms of Laplace. In this case, for example, we have to keep in mind that if this is our function f of x and this is the Laplace transform of our function, this one is a direct transformation. So for example, if we have e to the power of ax, the direct transformation of the by means of the Laplace transform is 1 over s less a, the coefficient that was in the exponent. This is the direct transformation. We are using this transformation right quick in this example, so keep it in mind and let's start to do the calculations. In this case, if we take Laplace transform in the equation above, so we take Laplace of the overall equation in both sides of the equation, so also in the right hand side of the equation. By the linear property of Laplace, we know that we can decompose this in its inner terms, so Laplacian of y prime plus Laplacian of y equals 3 times Laplacian of e to 2x. Alright, said this is a direct transformation using Laplace transform, so this is giving us 3 times 1 over s, parameter of the Laplacian, minus a. In this case a is 2, so this is the fraction that we are considering. The first one is L of y, and this one is S L of y plus the initial value condition, that is 0, as we know. So in fact the 0 is vanishing in this equation. We can cancel it, it doesn't matter. This value is 0, its value. So what we can do here is just factorizing this term, and what we get is the L of y, the Laplacian of y, times s plus y, s plus 1, sorry, has to be equal to 3 over s less 2. Or in other words, the Laplacian of y equals 3 over s plus 1 times s minus 2, right? So let's clear a little bit here above. What we can do now is factorize this term. We know that 3 over s plus 1 times s minus 2 equals a over s plus 1 plus b over s less 2, and this has to be the same as a times s less 2 plus b times s plus 1, and divided everything by s plus 1 times s less 2. So if these three terms have to be equal or the same, and the factorization is correct, what we can see is that if the denominators have to be equal, are the same, then the numerators have to be the same. So we can write just only the taking notice of the numerators. We can write that 3 equals a times s less 2 plus b times s plus 1. Just looking at the numbers, right? So developing this equation, we get 3 equals, we are rearranging the terms. So s times s brackets times a plus b plus the independent term is 1 plus b less 2 times a. And of course, over here there is a missing term, but in fact it's appearing. It's like if it were a 0 multiplying s. So now we can equate every term, only the coefficients at this time. So the s coefficients are giving us 0 equals a plus b, and the independent term 3 equals b less 2 times a. So this is a system of equations, linear system of equations. From the first one we get that b equals is minus a, and back substituting in the second equation 3 equals b less 2 times minus is positive, 2 times b, so is 3 times b. So b is equal to 1, 3 divided by 3, and then substituting above, a equals minus 1. So let's write it over here, over this equation. A is minus 1 and b is 1, so put it right quick. Okay, we clear below and continue. And this was our Laplacian transform of y. That's true. So what I can say is, clear this term. What I need to do is calculate the inverse transform of Laplace. If I want y, and this is the explicit equation, so the solution that solves this ODE, y equals minus the inverse Laplace of 1 over s plus 1 plus, or let's finish the bracket, plus the inverse of Laplace transform of 1 over s less 2. As we know, minus the inverse transform of this Laplace of 1 over s plus 1, we have to keep in mind the translation formula of Laplacians. So this is giving us exponential to the power of minus x times 1, that's the coefficient, is this term, the numerator, plus the second term, using the translation formula. The sign is negative, so it's e to the power of 2 multiplied by x, and again times 1. So rearranging terms, we can say that y is e to 2 times x minus less e to the minus x. So this is the solution, or should be the solution, of this ODE of first order ODE. Okay, to see that, it should be convenient to prove that. To prove that is just substitution, so it's just what we have to do is derivate this solution, the guess of the solution. If we do that, so y prime equals, just using derivatives, 2 times e 2 times x minus times minus is positive, e of minus x. And if I substitute this y prime in our ODE, in our differential equation, just 2 times e to the power of 2x plus xe to the power of minus x plus y, this term, equals 3 times e to the power of 2 times x. So transferring this term to the right hand side, all these terms, and in fact clearing y, what we get is y equals 3e 2 times x minus 2 times e to 2x minus e of minus x. So these two terms can be these two terms are giving us e to the power of 2x less e to minus x. That was precisely our guess of the solution. So we have given evidence that this solution is correct. So this solution is the solution of this ODE that we solved. So the Laplacian transformations are doing good. Thank you.